Module 7 Chemical Reactions and the Mole. Chemical reactions are the basis of chemistry as they involve the transformation of one or more substances into new substances. In this chapter, we will explore chemical reactions, including oxidation and reduction reactions, balancing reaction equations, identifying products of various reactions, and the mole as a unit of measuring the quantity of a chemical product. Chemical reactions. Chemical reactions involve the breaking and forming of chemical bonds, resulting in the transformation of one or more substances into new substances. The reactants are the starting substances in a reaction, while the products are the new substances formed. Chemical reactions can be classified into various types, including synthesis, decomposition, combustion, acid-base, and oxidation-reduction reactions. Oxidation-reduction reactions. Oxidation-reduction reactions, also known as redox reactions, involve the transfer of electrons between reactants. Oxidation refers to the loss of electrons by a substance, while reduction refers to the gain of electrons by a substance. Redox reactions are common in many biological and chemical processes, including respiration and photosynthesis. An example of a redox reaction is the reaction between copper and silver ions in a solution, which results in the formation of a solid copper metal and the reduction of silver ions to form silver metal. The balanced chemical equation for this reaction is 2Ag positive plus Cu, 2Cu2 positive plus 2Ag. In this reaction, copper metal Cu is being oxidized, as it loses electrons to form copper ions Cu2+. At the same time, silver ions Ag+, are being reduced as they gain electrons to form silver metal Ag. Balancing reaction equations. Balancing reaction equations involves ensuring that the number of atoms of each element in the reactants is equal to the number of atoms of each element in the products. This is done by adjusting the coefficients in the equation. The coefficients represent the number of molecules of each substance, while the subscripts represent the number of atoms in each molecule. Identifying products of various reactions. The products of a reaction depend on the reactants and the type of reaction. For example, a synthesis reaction involves the combination of two or more substances to form a new substance, while a decomposition reaction involves the breakdown of a substance into two or more simpler substances. Acid-base reactions involve the transfer of a proton from one substance to another, while combustion reactions involve the reaction of a substance with oxygen to produce carbon dioxide and water. The mole. A mole is a unit of measurement that chemists use to count the number of atoms or molecules in a substance. It is similar to how a dozen is a unit of measurement for counting things in groups of 12. The number of particles in a mole is a very large number, which is approximately 6.02 times 10 to the 23rd power. This number is called Avogadro's number. To convert a number of moles to grams, you need to know the molar mass of the substance. The molar mass is the mass of 1 mole of the substance expressed in grams per mole. To determine the molar mass of a substance, you need to know the atomic mass of each element in the compound and the number of atoms of each element in the molecule. To calculate molar mass, you first need to find the atomic mass of each element in the compound. This can be found on the periodic table of elements. The atomic mass is usually listed beneath the element symbol. Next, you need to multiply the atomic mass of each element by the compound of atoms of that element in the compound. This will give you the mass contribution of each element to the compound. Finally, you add up the mass contributions of each element to get the molar mass of the compound. The molar mass is expressed in grams per mole. For example, to calculate the molar mass of water, H2O, you would find the atomic mass of hydrogen 1.008 and oxygen 15.999 on the periodic table. Then you would multiply the atomic mass of hydrogen by 2 since there are 2 hydrogen atoms in water and add it to the atomic mass of oxygen. This gives you 2 times 1.008 plus 15.999 equals 18.02 grams per mole. Therefore, the molar mass of water is 18.02 grams per mole. To convert moles to grams, you simply multiply the number of moles by the molar mass of the substance. For example, if you have 2 moles of water, you would multiply 2 moles by 18.02 grams per mole to get 36.04 grams of water. Using the molar mass in chemical equations. The molar mass of a substance can be used to convert between the mass of a substance and the number of moles of the substance. This is done by dividing the mass of the substance by its molar mass to obtain the number of moles. The number of moles can then be used in chemical equations to calculate the amount of reactants or products.